Hello, everybody. We're going to talk about rationalizing denominators. You'll notice that this looks an awful lot like your homework worksheet. That's because it is the homework worksheet. What you're supposed to do on your own is the odds, and together we are going to look at some of the evens. So rationalizing the denominator means that we're going to set the denominator so that it has no more radicals left. So in the example they showed us, the original fraction was this one, 1 over the square root of 2. If you multiply the square root of 2 on the top and bottom, then you get the square root of 4, and you get the square root of 2 on top. And you can take the square root of 2, which is 2, and so now you have no more radical in your denominator. Let's look at number 2 together. Because we have the square root of 3 on the bottom, if we multiply both the top and the bottom by the square root of 3, we'll get rid of that. So the square root of 3 times the square root of 3 equals the square root of 9. And this becomes 2 times the square root of 3. And we leave 2 square root of 3 on top, and the square root of 9 on bottom is 3. Let's do another one, looking at example 4. Multiplying both the top and bottom by the square root of 2 gives us 6 square root of 2 on top, and square root of 2 times square root of 2 is square root of 4 on bottom, and we can take the square root of 4 because it's a perfect square, and we get 2, and we have 6 square root of 2 on top. Now, take note, these can be reduced, so 6 divided by 2 is 3 square root 2 for your final answer. Let's go ahead and skip down a little bit and do a couple more evens. Let's do 10 and 12. So we have multiplying the bottom by square root 3 and the top by square root 3. We get the square root of 3 over the square root of 9, which is the square root of 3 over 3. 12, let's first look at it and see, do we need to multiply anything? I actually see right here that 16 is a perfect square already. So really what I have is 1 over 3 times 4, which is just 1/12. Let's go to page 2. Let's look at 16 and 18. 16, we're going to multiply the bottom and the top times the square root of 12, and that's going to give us the square root of 12 over the square root of 144, which is the square root of 12 over 12. You may be starting to notice a pattern. Notice how when we multiply the numerator and the denominator both times the radical that's in the denominator, it comes out to be the number that's inside, comes out to be the original radicand on the bottom. So if I look at this one, and on this one, I'm needing to just notice that this is a perfect square. So I have 12, and then the square root of 36 is 6, and that actually reduces to 2. Let's go down to 22. Notice that I'm going to be multiplying both the top and the bottom times 27, or times the square root of 27. So that actually will leave me 18 square root 27 over 27, because I already know that if I multiply square root of 27 times square root of 27 and then take the square root, I'm going to be back to where I started. Now I need to ask myself if this can be reduced at all, and I know that 18 and 27 can both be reduced by or divided by 9. So if I divide this by 9, it becomes 2. If I divide this by 9, it becomes 3. And so my final answer would be 2 square root 27 over 3. Let's go ahead and do one more. I'm going to multiply both the bottom and the top times the square root of 2. That leaves me with 8 square root 2. And this will be over 3 times, and then the square root of 2 times square root of 2 is square root of 4, which leaves me with just 2 when I take the square root. So I get 8 square root 2 over 6. And again, take note that those are both divisible by 2, so this will become 3, and this will become 4. And so I get 4 square root 2 over 3. Have fun completing the rest of this worksheet.